This is a system of three equations. One appears to be a circle. There's a parabola and a line. The solutions are where they intersect, which they all three intersect here and here, nowhere else. So there are two solutions. They're telling us that this system has infinitely many solutions. What that suggests is that we are able to cancel out the x's and y's and we're left with a true statement. For example, if I triple this top and double this bottom, I have 6x plus 12y is equal to 36, and I also have 6x plus 12y is equal to b. Well, actually that would be 2b because you distribute the 2. So since everything on the left is identical, then I can say that 36 is equal to 2b. The answer is 18. Here's a system of three equations. We're looking for where they intersect, all three of them. So this one here has both lines and the parabola. This one has one line in the parabola, but not enough. This one down here has one line in the parabola, but not the other. There's only one solution. How many different values of x satisfy the equation above? If I distribute the negative 3, I have 10 minus 3x minus 6 is equal to 3x plus 4. If I combine like terms, this is what I have. The problem is that the x terms are not the same. So I have to add 3x to both sides. And I have 4 is equal to 6x plus 4. So 0 is equal to 6x, and I have one solution. How many solutions does the given system of equations have? So this is 4x plus 2y is equal to 20. If I'm just looking at the ratios of the coefficients, 1 to 3, it's not the same. And I could solve this in a couple different ways, but there's going to be exactly one answer here. So it would be possible to have 0 or infinite if the coefficients cancel each other out, which they don't, and you're never going to have exactly 2 for a linear system. On the left side, I'll combine like terms, so I have 3.5x minus 7. On the right side, I'll distribute, so I have 3.5x minus 49. If I subtract 3.5x from both sides, they go away, and I'm left with a false statement, which means that there are no solutions. So if I take 4x divided by 2, that's 2x, and then I have plus b over 2. You can split the fraction that way. And if it has infinitely many solutions, then this is the same. 2x and 2x match, so what could I plug in for b to make this 8? And the answer is 16. In the given equation, k is a constant. If the equation has exactly one solution, which of the following cannot be the value of k? So for linear systems like this, the only other possibilities are infinite or no solutions. So it turns out if you plugged in a 3 and doubled everything on the right, you'd have infinite solutions. Or if you plugged in a 6, you would cancel out the 6 w's and you'd have a false statement, which would be no solutions. That's the only one that's listed here, B. They tell you that this one has infinitely many solutions. So if we distribute like this is our new equation. So 8x minus 2x is 6x minus 2cx is equal to x. So 6 minus 2c is what's left after we factor out the x. So what can we plug in for c to make this equal to 1? If we subtract 6 from both sides, we get that negative 2c is equal to negative 5, or c is equal to 5 over 2. If I distribute the 2, I am going to have 3x minus 8 on the right and 3x minus 8 on the left. Since they're the exact same, that means infinitely many solutions, because if I cancel everything out, I get 0 equals 0, which is a true statement. We're looking for exactly one solution, so that means 0 and infinite are no-go. So if there were 3, that would be infinite. Can't have that one.